In section 7.3, you changed exponential equations into logarithmic equations, and you also changed logarithmic equations into exponential equations. The other thing that you did was to change a logarithmic expression into an exponent. So you change the logarithmic expression into just a number. And then we also graphed the exponential function and the logarithmic function, and you could see that those two functions are inverses of each other. Now, logarithms are exponents, and since they are, you can derive the properties of logarithms from the properties of exponents. So we're going to add some logarithms together and find out when you can do that and how to do that. So remember back when you multiplied powers with the same base, you had to add the exponents. So this is what it looked like. We had two bases that we multiplied together and they were the same, and then you just added the exponents. So that's where the product property comes from. You can kind of relate that to the properties of exponents. So if we start out with log base 3 of 1,000, we can break this 1,000 down into 10 times 100. Since this is multiplication, like here, we change it to addition, and we write the logarithm twice. So log base 3 of 10 times 100 gets split up into log base 3 of 10 plus log base 3 of 100. And you can use that property back and forth depending on what your problem is. So let's look at some values here. I have log base 3 of 243, and I rewrote it as log base 3 of 9 plus log base 3 of 27. And these two sides of the equation are equivalent because if my bases are the same and I'm adding, I multiply these two numbers together. Now, when you simplify logarithmic expressions, the goal is to turn the logarithmic expression into an exponent, and the product property can be used in reverse order to, and I want you to add the word simplify here, so in order to simplify logarithmic expressions. Now, in order to simplify logarithms, they must have the same base. So I have a problem here, and I have some steps that you need to check. First, make sure that the bases are the same. And here they are. They both have a base of 6. Okay, now the product property says that if our bases are the same and we're adding two logarithms, then we take the numbers that follow the base and we multiply them together. So express as a single logarithm using the product property. So we only write the log base 6 one time, and then we multiply the two numbers together. So this would be log base 6 of 4 times 9. And then we simplify if possible, which means we want to change it just to a number or the exponent. So we now have log base 6 of 36. And from yesterday we know that this question is actually asking us, what power do you raise 6 to get 36? Well, the answer is just 2. 6 squared, so the question here is 6 to what power equals 36? And that would just be 2. So this whole expression can be changed to just the number 2. That's how we simplify. Our goal is just to get it to a number. All right, now there's another property that you can use when you're dividing logarithms. Now remember what happened when you divided logarithms with base, or not divided logarithms, but when you had powers with the same base, you subtracted the exponents. So let's look at what this looks like, just as a reminder. We had two bases that were the same. When we divided, we subtracted the exponents. So that's going to transfer over to the quotient property of logarithms. When you have a logarithm, this is base 5, and we have 16 divided by 2, I can split that up into two logarithms, and I can say log base 5 of 16. Because it's division, I'm going to put a subtraction sign in between the logarithms, and then I have to write the log base 5 again of 2. So this is, again, about rewriting, and you can go back and forth depending on what type of a problem you have, which order you want to do it in. So I could have something like this, log base 2 of 15 divided by 33. And if I want, because this is division, I subtract these two numbers, but I have to write a log base 2 in front of both of them. So I say log base 2 of 15 minus log base 2 of 33. All right, so here is an example. We first want to check to make sure that we have the same bases, and here we do. And then the next thing that we want to do is express as a single logarithm using the quotient property. Now the quotient property says that I can take these two, and it's in reverse order. I can take these two logarithms, write them as one logarithm, and then if I do that, I have to divide the first number by the second number. So that's going to look like this: log base 5 of 100 divided by 4. So basically that's log base 5 of 25. And then I want to try to do the same thing. Now from yesterday, we learned that we could replace this with the exponent that we find that we raise 5 to get 25. So that would be 2. So the logarithms are exponents. So I'm rewriting log base 5 of 25 as the exponent 2. So again, we rewrote this long expression here, and it ended up just being 2. So we simplified that quite a bit. Now, on the other side, we have the logarithm of a power is the product of the exponent. So the product of the exponent and the logarithm of the base. So if that's a little hard to follow, just remember that the power property of a logarithm is what you use when you're working with logarithms that have exponents. So you'll only use this if you have exponents or if you have a number in front that you want to bring up into the exponent. This one goes both ways as well. You can take the exponent and put it in front of the logarithm. You can take the number and bring it back up to the exponent. Okay, we want to express the following problems as a product and simplify if possible. Okay, now here we're going to have some exponents. So what this power property allows me to do is bring the 6 out in front of the logarithm. And when I do, it looks like this. So we have 6 log base 2 of 32. And then I can switch this. I'm asking myself, what power do I raise 2 to get 32? So I can change this to the exponent, which is 5. So now my problem turns into just 6 times 5, which equals 30. So before I can change this to an exponent, I have to get rid of this exponent. So I bring that exponent out in front, and I can do that because of the power property. And then I change this logarithmic expression to 5, and then I can just multiply, and I get one value here for that expression. Okay, now the next one, I can do the same thing. I can take the exponent out in front. So yesterday we just worked with problems like this. Now we have exponents on them, but it's really just one more step. We take the 4 out in front here. So it's going to look like this: 4 log base 3 of 1/3. Now, from yesterday, we can simplify this to an exponent, and log base 3 of 1/3 is just going to be -1. So then I can multiply those two together, 4 times -1, and my answer is just -4. So you can switch back and forth within each of these properties. So in other words, you can write a logarithmic expression as a sum of 2 logarithms, or you can write 2 logarithms as a single logarithm using the product property. That same thing goes for the quotient rule as well. All right, a couple of examples for you to try.